Okay, tonight we're going to begin looking at the second part of extending the number system, which will be looking at properties of exponents. So right here are the rules. We're talking about 5 different rules that we're going to be looking at. And we will look at each one of these rules individually. So if you want to come back and use this as a reference, you can, but we're going to have each rule on each page. The product of powers property says that if you multiply powers with the same base, you want to add the exponents. So in the first example, I am multiplying because I have a dot. The bases are both 2, so I can use the rule to add the exponents. So I would say 2 to the 1/2 power plus 3/2 power. I've got a common denominator, so that will give me 2 to the 4/2 power, which I can simplify 4/2 to be 2 squared. Next example, I want to do the same thing. Dot means I'm multiplying. I've got the same base, so it tells me to add the exponents. So I'm going to say x to the 3/4 power. Add the other exponent, 5/4 power. Got a common denominator, so that gives me x to the 8/4 power, which I can simplify 8/4 again to be 2, so x squared. The last example, using the product of powers property, again I'm multiplying, so that's the product. I've got the same base, so I'm going to add my exponents, so I'm going to say x to the 2/5 plus x to the 3/10. And that's where we got to go back and remember what we did with our denominators, because we have to have a common denominator. So that's going to give me, if I multiply here, that's going to give me 10 as my denominator, or 50. 5 times 10 is 50. Cross, 10 times 2 is 20. And 3 times 5 is 15. If I add 20 and 15, I get 35. So I can simplify that by a factor of 5, x to the 7/10. Now since that's a radical exponent, or a rational exponent, I could make that into a radical expression. That's the 10th root of x to the 7th power. Both of these are correct answers. The next property we want to look at is the quotient property. Quotient means to divide. So if we divide powers with the same base, remember they have to have the same base, then what we want to do is subtract the exponent. So we have the same base, x. We have a fraction bar that indicates divide, so we'll have a quotient. We're going to use the quotient rule. So that tells me to subtract the exponents. So my base is x. My exponents are 5/8. Subtract 3/8. And if I subtract those, that gives me x to the 2/8. I already have a common denominator. It makes it easy. Reduce by a factor of 2. So x to the 1/4. That would be my exponential expression. I could write that as a radical expression. So I have the 4th root of x to the 1st power. So I can just leave it plain x. For my second example, again, I have a fraction bar that indicates it's going to be a quotient. So I want to subtract my bases, or my exponents. So I've got x. I want to subtract 2/3. That's my exponent, my numerator. Subtract 1/4. That's my exponent, my denominator. Remember, when you subtract exponents, you've got to have a common denominator. So let's multiply here. That's going to give me x to the 3 times 4 is 12. Cross and get 8. Cross and get 5. 8 plus 5 is, or minus 5, I'm sorry, is 3. So that's going to reduce to give me, I messed up. Three times 1 is 3, and 8 minus 3 is 5. I can't reduce that, so that is my exponential expression. If I want to write that as a radical expression, my root is 12. to the x, that's my base, and my exponent is 5. Okay, this is the power of a power. So if I'm raising one power to another power, I'm going to multiply the exponents. So here I've got x squared raised to the 2/3 power. So I'm raising a power to a power. So that tells me to multiply my exponent. So I'm going to multiply the exponent 2 times 2/3. And remember, when we multiply exponents, we do not have to have a common denominator. I keep my base x. I multiply the numerators. 2 times 2 is 4. There's nothing to multiply the 3 with, so I leave it 3. That is my exponential expression. My radical expression, my root would be 3 because it's the denominator, over x, that's my base, to the 4th power. That would be my radical expression. Here's another example. If I want to raise x to the 4/5 power to the 1/8 power, power to a power, I keep my base x. I say 4/5 times, I'm multiplying because I'm raising a power to a power, 1/8. So I multiply numerator times numerator. That would give me 4 times 1 is 4. 5 times 8 is 40. I can reduce that by a factor of 4. So x is 1 over to the 1/10 power. That would be my exponential expression. My radical expression, my root would be 10 because it's my denominator, over x to the 1st power, and it's understood. So there's my radical expression. Okay, here's another property, power of a product property. To find the power of a product, distribute the exponent. Notice now I have more than one base. So what that's telling me is that I have to give each base the power. So if I have, that would give me x to the 1/4 power and y to the 1/4 power. That would be my exponential expression. My radical expression, my root would be 4 because it's the denominator. 4th root of x times, again, the 4th root of y. That would be my radical expression. Here's another example. Again, I've got two different bases. So I'm trying to raise both of those bases to the 1/2 power. So I'm going to say x to the 1/2 times 1/2. And the other base y, 3/4 times 1/2. If I multiply my exponents for each base, 1/2 times 1/2 is 1/4. Do the same thing with y. 3/4 times 1/2 is 3/8. That again would be my exponential expression. My radical expression would be the 4th root of x times the 8th root of y to the 3rd power. Either answer is correct. Last property, power of a quotient property. To find the power of a quotient, distribute the exponent. So that wants me to distribute the 1/2 to both the x and the y. So my numerator is going to be x to the 1/3 times 1/2. That's my numerator. My denominator would be y to the 1/2. So if I simplify that, I'm going to multiply my exponents in my numerator. 1/3 times 1/2 is 1/6 over y to the 1/2. That would be my exponential answer. If I wanted to express it in a radical answer, I have the 6th root, because it's my denominator, of x to the 1st power, understood 1, to the square root of y is my denominator. So there's my radical expression. So we're going to work some more on these. Of course, they'll be more complicated in class, but that gives you a good idea of what each property allows you to do.